All right, Algebra 2, we are going to, now that we've been through factoring, we did factor by grouping, we're looking at trinomials. We're going to look at a couple special cases here. And the two things that we want to highlight, and this is back in our regular notes here, is a perfect square trinomial. I think when I ask you to make this, this might be one of the more frustrating things to try and figure out until you really get it. So I'm going to try and do a really job and go slow through this. Okay, so what we're going to notice is we have a perfect square in the beginning and a perfect square in the end. So yeah, can I do 4 times 36 and figure this out and never use the shortcut? Absolutely. But I don't think anybody wants to do that. So when you notice that you have some perfect squares, this one has a GCF, so I don't really care for this one. I'm going to give you another one in just a second here. But if you notice that this is a perfect square, so let's check this out. So the square root of 4x squared is just 2x, and the square root of 36 is 6. So here's what I want to check. Do I have plus here? Yeah. That means the signs are the same, both negative. And the last thing I want to check is if I do 6 times 2, I get 12. That means I need two of these, right? So in this kind of shortcut, this idea to put it all together, I'm going to do 2 times 6 is 12 times 2 is 24. And that gives me the number that's in the middle, which tells me this is a perfect square trinomial, right? If I didn't get 24, which is the magic number here in the middle we're trying to get, then this isn't a perfect square trinomial. It isn't something I can do. It's just I gave you something that had some perfect squares, but we didn't have the right b value. All right, so here's what it looks like. All right, so let me give you another one. So I want 9x squared because it's perfect, right? I want plus 24x and let's say plus 16. So first thing you're gonna do, you're like 9 times 16. You're like, no, whoa, 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 I don't want to do that, right? Because we spent a couple important minutes here and we talked about this. So what's the square root of 9? 3. So I need 3x. What's the square root of 16? It's 4. Okay, signs are the same, both positive. Okay, so 3 times 4 is 12 times 2 gives me, bingo, 24. So that means this is a perfect square trinomial. And all that means is we can write it as a binomial squared. So remember, one of the keys here is you're going to have a plus sign on the end, right? So plus sign in the end, because the signs have to be the same, right? If it's a binomial squared, that means the same thing twice. All right, so let's see if you can guess this one. All right, let's go with, let's use that 9x squared again. Plus, I'm going to ask you what goes in the middle. And let's say plus 25, right? Those aren't too bad to work with. Okay, so let's see if you can figure this out. Remember the first one, we're going to go 3x. The last one's 25 is 5. Signs are the same, both positive. So I want this to be squared. So what number would have to go right here for this to be a perfect square trinomial? Right? I don't just like to draw W's, right? This is 3 times 5 is 15 times 2. This has to be 30x. All right, so if 30x was in the middle, then this is a perfect square trinomial. And that's how it works, okay? Let's give you one more. Let's go with 25x squared. Let's use minus this time, plus 64. Those perfect squares? You betcha. All right, so first of all, what's the binomial have to be? And we're going to make sure this works by making this happen. So this might be seem a little bit backwards, a little advanced since we just got into it. But if you can do this in reverse, you can definitely do it the way it is. Okay, so I got 5 squared. I got 64, that's 8. So what has to be in the middle? Awkward pause while you think about it. 5 times 8 times 2. What did you get? 80x. All right, so if I gave you 80x in the middle here, right? So you'd be like 25 times 64. You're like, no, I don't want to do all that. That seems weird because these are perfect squares. So square root, square root. Signs are the same, both negative. And then you do the W to double check it to make sure you got 80. All right, now, mind you, you could work through all these problems without knowing that little trick. And I wouldn't say it's a trick, it's a perfect square trinomial. So it's very, very helpful in some of these larger setting problems. All right, notice the second one is also dealing with a difference of squares. So we're dealing with squares. Squares are awesome, right? Until they're not. And what we have here, this one has to be a difference. This only works when it's subtraction. Only works when it's subtraction for squares. And what we're going to do is we're still going to take the square root, right? We'll get a and a, take the square root, we'll get b and b, and then need 1 plus, 1 minus. Right? So I don't have to double check anything. As long as they're both perfect squares, we're good. We're just going to write a little bit more on this one, okay? So I get 5x, 5x, 7 and 7, 1 plus, 1 minus, done. How do I know it works? Well, they're conjugates, right? So the outside would be negative 35, the inside is positive 35. They're gone. All right, let's try another basic one. Let's try that 9x squared minus 64. Yeah, we just talked about that one a minute ago. So here we go, 3x and what, 8? And I need 3x and 8. 1 plus, 1 minus. The order doesn't matter as long as we got one of each of them. Okay. Now, I could try and mess with you, and I'll do that at some point, right? 25 minus, let's make this 4x squared. Right? Notice it's kind of flip-flopped, right? We like to see the x thing first. Don't change it back. Okay, so this is 5 and 5. This is 2x and 2x. 1 plus, 1 minus. Okay, so this is pretty normal on standardized testing. They want to try and do something like this to try and kind of throw you off the trail that you are dealing with a difference of squares. But as long as they're both different, subtracting, and perfect squares, you're good to go. All right, I had one more over here. We're going to up the ante just a little bit because this is algebra 2. You know what I mean? So square root. So 16 is 4x squared and 4x squared. 81 is 9 and 9 plus and minus. All right, now this guy here, the plus, it's done, right? Because it's a plus sign. But notice what happens in our second one. You now have, my friends, dun dun dun, an onion. Right, this thing is layered up again. These are both perfect squares. 2x and 3, 2x and 3, 1 plus, 1 minus. So what's my answer? It's all three of these to get into factored form. All right, so watch out when we up that power right here. Oh, that was a bad color choice, but you guys see it on your paper there. All right, so that was a big 4 right there, or a little 4 because there's an exponent. Get it? Little 4? Okay. Either way, that's where we want to be at. So when that power goes up, make sure you're looking for maybe another layer of it, just like we talked about in some other problems so far this year. All right, that's all for now. Peace.